When we discuss cloud computing today, we usually fall into two camps. On one side, we have the total control and management overhead of Kubernetes, and on the other side, we have the total abstraction of functions. But there's a middle ground that has quietly become the backbone of efficient production systems, and that is Google Cloud Run. And it's often overlooked because it doesn't fit the serverless or the IaaS labels perfectly. It's a managed platform that runs OCI or Open Container Initiative compliant containers, but with a request-aware scaling engine. In this video, we're gonna explore why this service is the precise tool for architects who need to balance portability with managed scale. Now, to understand Cloud Run, you have to understand the container runtime contract. So, unlike virtual machines where you manage the operating system or a function where you manage just the code, Cloud Run asks for one thing: a container that listens to specific requests on a specific port. Now, what makes this contract so powerful is the environment it runs in. So every Cloud Run instance runs in a specialized sandbox called gVisor. This is a user space kernel that intercepts system calls, offering two major advantages. First, we've got security, as it provides a strong isolation between your code and the host, giving you the security profile similar to a virtual machine, but with the 2-second startup speed of a container. And because it's a container, you're not limited by language runtimes, and thus giving us compatibility. Now, the most significant technical feature of Cloud Run is concurrency. So in standard serverless environments, 100 simultaneous requests means 100 separate instances. But in Cloud Run, the default is 80 concurrent requests per instance, and you can level this up to 1,000. And the reason why this is a technical game changer is because of request-based scaling. So Cloud Run doesn't just scale based on CPU usage, but it looks at active requests. Also, if your app is waiting on a database, a single instance is capable of handling dozens of users simultaneously. So this drastically reduces cold starts because you're not spinning up a fresh server for every person. Now, in 2026, the biggest shift is on-demand GPUs. So traditionally, AI inference required GPU clusters running 24/7, but with Cloud Run, you get GPUs on demand. And with Cloud Run, we mainly get two powerful GPUs. First, we've got the NVIDIA L4, which is perfect for high-speed inference with Gamma 3 or Llama 3.18b. And this requires at least 4 virtual CPUs and 16 GB of RAM. The second GPU is the NVIDIA RTX Pro 6000 Blackwell, now still in preview. This GPU allows you to serve massive 70B plus parameter models without managing a single server. Now, in essence, when a request hits your API, Cloud Run spins up a container with the attached GPU in under 5 seconds. So you pay for GPU seconds only, and when traffic drops, your GPU bill scales back to 0. Now, there's a misconception that managed containers are too simple for enterprise networking. Now, that has changed with sidecar support and VPC or direct VPC egress. Basically, with sidecars, you can run helper containers like logging agents or auth proxies alongside your main app. And with the direct VPC egress, you can forget about the slow serverless VPC access connectors. Direct egress allows your containers to talk to private databases on your internal network with higher throughput and lower latency, all while scaling down to 0. Now, when working with Cloud Run, you need to distinguish between services and jobs. So, services are for request-driven workloads like APIs or webhooks that need to respond in milliseconds. And jobs are for run-for-completion tasks like data migration or batch AI fine-tuning. And a job can run for up to 24 hours or even 7 days for non-GPU tasks, and this provides a much more predictable environment for heavy lifting than a standard web service. Now, enough theory, we're gonna build a production-grade AI translator microservice. We're gonna use the latest Gemini 3 Flash to handle sub-second translations into Spanish with structured JSON output. Now, once we're in the Google Cloud Console, we're going to head over to the Cloud Shell. And once we're in the Cloud Shell, we're going to create a directory called Translator API, and then we're going to navigate to that directory. Now we are in the correct directory. We're going to head over to the Cloud Shell editor, and we're going to create two files within that directory. First is the requirements.txt. So we're using the 2026 Unified Google Gen I SDK. So this replaces all the fragmented libraries of the past with a single high-performance client. The second file is the main.py or .python. Of course, this is the brain of our operation. So we're using FastAPI to handle the web requests and Pydantic to define our data contract. So notice the thinking level parameters. So for a translator, we set this to low. So we don't need Gemini 3 to solve advanced physics here. We just need it to move fast. So this setting reduces latency by up to 40% while also maintaining pro-grade accuracy. Now, time to ship. We run the gcloud run deploy command. So this uses build packs to automatically detect our Python app, wrap it in a container, and host it on a public URL. Of course, remember to put your Google API key from AI Studio or from Google AI Studio. So you simply follow this link right here, and then you can click on the key and then simply click on copy the key. So now you've got the key copied. You can paste it in your code. Now the terminal says done. The URL is live. Of course, we're going to need that specific URL. Now this is the moment where our Python code, our container, and the Gemini 3 model all have to work together in under 2 seconds. So we're going to capture the service URL as I said. So after the deployment finishes, we're going to copy the service URL provided by Google Cloud, of course, and in the terminal, we're going to save it as a variable to make the test command clean. And now we're going to run this command to send an English sentence for a translation. So this mimics exactly how a real client like a mobile app talks to your service. And as you can see, we get back a clean JSON object. Of course, we're talking about a Spanish translation of our English sentence. Now in the professional world, the client isn't usually a person typing curl. It's actually another piece of software. So it could be a mobile app or a website, and they don't need to install Python or AI libraries. They just need to know how to send requests to your service. Of course, if the client app goes viral and sends 50,000 requests at once, your Cloud Run service instantly scales and handles it, so the client never experiences a service busy error. Now that's it for today's video. I hope everything was clear. If you have any questions, drop them in the comments below. If you want to learn more about cloud and IT, check the link in the description below. Don't forget to hit that like and subscribe buttons, and I'll see you in the next video.